Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating article. Haskell, a great procedural language. It challenges conventional wisdom about Haskell, arguing it's surprisingly well suited for procedural programming. Intriguing, right?
Absolutely. I've always seen Haskell as a purely functional language. This is a new perspective. What's the core argument?
The core idea is that Haskell's handling of side effects, often seen as a complex aspect, actually enables powerful procedural programming. It treats effectful computations as first-class values. Think of it like this. You can store them in variables, lists, even manipulate them like regular data before actually executing them.
So, you're not executing side effects immediately? That's unusual. How does that work in practice?
Exactly. The article uses the example of random RIO, a function generating random numbers. In most languages, calling it immediately produces a random number. In Haskell, calling random RIO creates a description of the computation, an object encapsulating the side effect, but doesn't execute it. You can store these descriptions in lists, manipulate them, and only execute them later.
Okay, I see. So the execution is deferred. But how do you execute them then?
Primarily through do blocks, which the article cleverly deconstructs. It shows that do blocks aren't magical. They're essentially syntactic sugar for the greater than then and greater than equals, bind, operators. Greater than chains side effects sequentially, discarding the result of the first, while greater than equals passes the result of one to the next.
That's a really elegant explanation. So beyond do blocks, what other tools does Haskell offer for procedural programming?
Oh, there's a whole arsenal. Pure creates side effect objects that always return a specific value. fmap transforms the result of a side effect, and lift_a2, lift_a3, etc. combine multiple side effects using a given function. It's incredibly flexible.
And what about handling collections of side effects?
That's where sequence_a shines. It takes a list of side effect objects and creates a new one that executes them all, returning a list of their results. There's also traverse, which applies a side effectful function to each element of a collection, and its more concise aliases, for. These are incredibly powerful tools.
This sounds remarkably similar to how you might structure asynchronous operations in other languages, using promises or async/await. Is there a connection?
Absolutely. The article explicitly mentions the similarity to JavaScript promises. Haskell's approach to side effects is a precursor to many of the patterns we see in modern asynchronous programming. It's quite prescient.
So what are the advantages of this Haskell approach?
Refactorability is huge. Because side effects are first-class values, you can refactor code without worrying about accidentally changing execution order. Plus, it enforces discipline, reducing the risk of unintended side effects and interaction bugs. It's a much safer way to do procedural programming.
I see. But isn't this all just syntactic sugar over monads? Isn't it just a more complex way of doing what other languages do more simply?
That's a valid point, and the article addresses the historical context of monads. While monads are underlying, the focus here is on the practical application and the surprisingly procedural nature of the resulting code. The higher-order functions like traverse and sequence_a abstract away much of the monadic complexity, making the code cleaner and more readable. It's about elegance and safety, not just raw power.
The article also mentions state monads for managing mutable state. How does that fit in?
State monads provide a way to manage mutable state within a purely functional context. The article uses it to implement a caching mechanism for a prime factorization function, showing how you can have local side effects without compromising the overall purity of the code. It's a powerful technique for optimizing performance while maintaining functional elegance.
This is truly fascinating. It completely changes my perception of Haskell. I never considered it a viable option for procedural programming.
Precisely. The article makes a compelling case that Haskell, with its unique approach to side effects, offers a powerful and safe alternative to traditional procedural languages. It's a testament to the flexibility and expressiveness of the language. It's a paradigm shift.
One last question. What about the Haskell is useless and Haskell avoids success claims?
The article addresses those as well. They're not dismissals, but rather highlight Haskell's commitment to its core principles, even if it means sacrificing some immediate popularity. It prioritizes safety and elegance over raw power or ease of use. It's a philosophical stance. Less than / person 1 greater than. Less than person 1 greater than. And that's a wrap for today's Tech Bytes and News. Thanks for joining us on this deep dive into the surprising world of procedural Haskell. Until next time, goodbye.
Bye-bye.